All right, guys, just to show you how to make the calculator do this for me, I can make L3, I can make it L1 times L2, pop! And then L4, L1 times L3, bam. Is that cool? Oh, yes. Is that what you guys got? Okay. Now, I could do the list sum, right? To get the sum of those lists 3 and list 4. You guys with me? But let me show you a little bit of a shortcut. If I do stat calc 2 bar stats, and I do it on L3 and L4, one thing it tells me the sum. So that's the sum of L3. And then down here it's got the sum of L4. So it says L3 is the x's, L4 is the y's. It sees them as 2 separate variables. Do you have to do it that way? No. You could do the stat sum, the list sum thing. Or you just add them up one by one in your calculator. Whatever you feel like doing. But is that what you guys got? 45.89? Sounds familiar. So that's the what? That's the mean. And then the standard, the piece of the variance would be, where'd it go? 2410.89. Now the big mistake, the big problem with doing it this way is people look at all these other numbers. None of the other numbers mean shit to me. All I wanted was the sum of each. That's the thing you have to be able to do if you want to do it this way. Just focus on the sum. Okay. So why is this a valid probability distribution? And if there's a question I ask on this side that doesn't make sense, there's an answer on the other side. It's kind of crazy. So I'm going to ask you this question, and if you don't tell me both things, you will lose points. So what 2 things have to be true?
It has to be between 0 and 1.
Yeah, every probability has to be between 0 and 1. And that to add up to be 1. Now, listen. You ready? I'm going to tell you something that I'm going to do on the test. You ready? I am going to make the sum something like 0.9999 or 1.0001. Is it still valid? Of course it is. Why? Why would that happen? Have we ever had that before where the probabilities didn't add up to be 100%?
Yeah.
Of course we had. Was it a problem? Not really, unless it was like 90, then you left a lot of shit out. But if I got 0.998, holy shit, why did that happen? Because there was rounding. So on a test, I'm going to make sure that the answer comes out to be not quite 1. Why am I going to do that? So you guys don't just write the shit without actually checking, right? I love the people that just put, yeah. I'm like, what? Did you even look at it? It doesn't have to be 1. So I've just told you something about the test to watch out for. And now I'm going to tell you the percentage of people that just do that anyway. Yes?
So if you want to just straight up put that, but equals 0.998.
Yeah. So how would you say it officially? You would say the sum of probability of x is 0.9999. But you wouldn't stop there because it makes it sound like it's supposed to be that. What would you say after that, which is close enough to 1?
So, like
so show me what it's supposed to be, but also show me that you actually checked it.
So when is it close enough and when is it not close enough?
I love it. I'm going to make it 0.9999 or 1.0001. The idea of close is something we sort of developed a little bit with standard deviations, right? Does not really play into this specific situation, but the idea of close is something we're going to define a lot better really soon.
You're saying it was like really obvious?
Right now, it's going to be really obvious one way or the other. Like it's going to be 0.9, that ain't close enough to 1. Or 0.9999, it's like, that's close enough to freaking 1, right? What if it was 0.981? Is that close enough? Oh, shit. Probably not, to be honest. But it's going to be really obvious for us since we haven't really defined what close enough is yet. All right, you guys sort of still with me? A little bit? Okay. This one was nice. It did add up to 1. Yay. Now, this is the one, this is a question I just asked just to make sure you can read the freaking table. What's the probability that somebody thinks they're going to be at least 25 when they retire? There's a shortcut and a long cut. So what percentage of kids thought they would be at least 25?
96.
Yeah, you can add all these up, or you could just do 1 minus that. So either way, you should get 96%. I like it. There's 4% of them that think they're going to create the next Facebook or whatever. Or the next, I don't know, what is it now? Snapchat, Instagram, TikTok, I don't know what this shit. Yes?
So, since like adding up all the probabilities doesn't always equal exactly 1, if you do it in 2 different ways, is there like a possibility of getting like slightly different answers? Because one way you're subtracting from 1 and then the other.
Oh, I see, yeah. In that case, yeah, I kind of allow either way. So I like people that are careful and actually subtract from like 0.9999 instead of 1. But if you do 1 minus, I'm not going to kill you because that's the general idea. So good point. I would take either way then. Yeah. Okay. So, yes.
0.4 is it says at least 25, so that means I would have mistaken it to 0.24, but it's not.
Oh, 0.24 is the probability that somebody thinks that they will be exactly 25. At least 25 is 25, or 40, or 50. So I would add all those up, but the shortcut, of course, is just 1 minus that. I like it. So this one we already got, straight up. We got 45.89 for that. This is what? 2410.89 minus 45.89 squared. People leave that square off all the time. Poor little square. So the variance comes out to be, I don't know, what do you guys think?
304.9979.
Dude. Yeah, what'd you say, 304.1079?
9979.
Oh, I left out the 0.89. Good job, Jeff. 9979, yes. 9979. There you go. That was easy. Sorry. And then, of course, to get the standard deviation, I just take the square root of that bad boy. So I square root. Get out of there, complex. Square root the answer, and I get 17.464. Now, let me show you something you wish I'd just let you do, but too bad I actually freaking try to teach you shit. If you have your data in here, can somebody help me out? Where is the data? Where is the complete data? Which list? That's sort of a trick question. Which list has the complete data?
Complete data for what question?
No, there's only one question asked.
At the end, the second one.
Second one's interesting. It's got the percentages, but it doesn't have their answers, does it? So if you say L1, that's the answers, but it doesn't represent how many people. Say L2, that's how many people. So where's the data? L1 and L2. You need both of them, right? I can't just say that somebody said 1. I have to say 30% of the people said 1. That's the complete idea of 1, right? And so forth. So why am I saying all this shit? How many variables are there? Oh, God. I always love this question. How many variables are there? Which is related to how many questions did I ask? Now, how many people did I talk to? How many questions did I ask in this problem? 1. When are you going to retire, kid? Hey, kid. When are you going to start working and then retire? So watch this. If I want to make the calculator do the mean and standard deviation for me so I can check my work, I hit stat, calc, 1var stats, but I tell it list 1, and the frequency list is list 2. Let's see if this looks familiar. Sorry. Yes? Maybe? Now, now watch this. What's this mean, this n equals 1? What do you think that really means? Was there just one person I talked to? No, in this case it's adding up the percentages. I like it. This will be a little bit off if this isn't exactly 1? So if you go to check your work on the test, and I already told you I'm not going to make this 1, this will not quite be exactly what you get. Doesn't mean you're wrong. Okay? Look how much I'm telling you about this problem on the test. We'll see how many people screw it up still. Okay. Do you even have to be able to know how to do this? No, because we already did it. It's just checking the work. Any questions on what we've done so far? Okay, I like it. So what does this mean? What's that mean? What's that number mean? You gotta be a little careful. It's how far the data points get away from the mean on average. So on average, the data points, the ages that said, get about 17 and a half years away from the average of what they said. Right? That's the average distance from the mean. Like it. And we should expect it to be kind of bigger because the numbers go from 21 to 100. Right? I like it. All right, now D should sound very familiar. I think I told you a while back I'm going to ask this question a lot. Right. So what goes in the middle? Dude. And then I just go up one of these. So where does that lead me to? And then I go down one of these. 28.4 something? All right, cool. And then I want to know, now watch, you can't just say so many out of 6. Because did I catch any 21s?
No.
No. 25s?
No.
40s. I caught all the 40s. So what percentage is that already by itself? 23%. What else did I catch? 50s. So that's 23 and 18 so far. Did I catch the 65s? Nope, not really. I like that answer. So then what percentage did I catch? Add these together. 41%. Kick ass. So it's different from when I just gave you a list of data because the percentage they're already sitting there waiting for you. You just got to add them together. You don't have to take it and divide by how many.
Can you repeat how you get the number?
Which one? These?
Yeah.
So here's the mean. And then I want within one standard deviation. So I add a standard deviation, I add one of these, and I subtract one of these. And then it just goes see what data points did I catch in that net. Kick ass. So that's a very familiar question with a little different way to do it now that the data is given to me differently. Now I love this question. How many kids believe they will retire before age 65? I got to do this in 2 steps. What percentage of the kids think they'll retire before age 65? Say again?
69%.
Yeah, 69%. I like it. You just have to add up the percentages that are before 65. So 69% believe so, but I want how many kids? Well, how many total kids were there? 1,200. So 69% of 1,200 is whatever the shit it is. I have no idea.
828.
Say again?
828.
828. So 828 kids think they'll retire before 65, but the retirement age will probably be like 75 by the time they get up there. Oh, the life expectancy went down a bit for us.
So we're just not retiring. This generation is.
Well, yeah, we're all living longer, so that means we're working longer so that we can eat longer, so we can live longer, so we can work longer. A never-ending cycle. How do you guys feel about that? There's several questions that sound familiar. It's a little bit different way to do things. Now, let me show you something kind of cool. A couple things. I put a little note on the board for myself. What happens when you turn 25? How many of you guys have turned 25 by now? You're older than, you're 25 or above. Is everybody in here less than 25?
Not me.
Okay. Hey, Linda. You turned 25, right? Yes? No? You were just stretching. Anybody else? Over 25, yes, okay. All right, so the rest of you, what do you have to look forward to as far as car insurance?
It gets
When you-
lower.
Yes, all of a sudden, when you wake up on your 25th birthday, you go,
That's the first.
oh, that's how you drive. Oh. And then, yes, we see the difference. Why? Obviously, that's not true. You don't wake up on your 25th birthday. It's like the car fairy came in the middle of the night and whispered in your ear. You really should use a blinker.
On some spreadsheet somewhere.
Yes, cool. So, what they do,
5-year-olds are safer.
let me do a very, 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 very simplified version of what they do. So basically your premium drops. So let's say this is really hyper simplified. I have no idea if the numbers are anywhere near correct, and I personally don't care too much because every car insurance company is going to have their own person doing this with different numbers. Because what do you have to tell them? How do you get discounts? If you drive to work or just for pleasure, because that affects the probability that you'll get into an accident, right? If you're going to work, you're probably less likely to be inebriated to any degree, right? Less likely, not impossible. So anyway. So let's say they expect to pay these amounts out for accidents. All right, just to pick some amounts. Now, obviously, it's a little more complicated than this, but it's basically this. And the probability that they'll pay these amounts, let's say it's, just make it super simplified. What do you got, Jeff? I like it. Okay. So that adds up to be 1, thankfully, right? So there's a 70% chance they won't pay anything over the course of whatever the long they're looking at. So 10% chance you'll be in an accident that costs around $100. 15% chance you'll be in an accident that costs $10,000. 5% chance. You guys get the idea. The numbers, I don't know, obviously. I don't do this job, but I know the work behind it. So if I calculate the mean, the other name for the mean, this is kind of beautiful. The formula for the mean is this. That's the formula. The other name for the average is expected value. That kind of makes sense, right? What's the average of all the numbers on a die? What's the average of all the numbers on a die?
Like 16 point something percent.
No.
Or
The average. So 1 through 6. Right? What's the average going to be?
3.5.
Okay, good. Right? So if I roll a die like 100 times, what do I expect the average of the rolls to be? 3.5. I expect that, right? I don't expect any number to show up more often than any other, so it should be kind of uniform. You guys with me? Will it be 3.5? No. Expected doesn't mean definite, right? So another name for average is expected value. And look at the first 3 letters in the formula. I always loved that. The minute I saw that, I'm like, holy shit. Right? Isn't that basically EXP, expected? No, good job, Jeff. That's not why we made the formula that way. It's just a happy coincidence. At least for me. Even if you don't care about it, I love it personally. So how much will they be expected to pay out for their clients on average per client? I just do this. So that would be 0, 10, I don't know. 1, 2, 1, 2, it'll be 150. 1, 2, 1, 2, that'll be 2,500, I think. 1, 2, 1, 2, yeah. And then I add these up, and I get, what do I get? 2660, really? 2660, yeah. Now this is for a certain category of people. Maybe they live very far away from work. Maybe they drive for pleasure a lot. Maybe they live in a bad part of town. Maybe they have a really old, gross car that doesn't even have a seatbelt, right? So how much should the insurance company charge? Let's say this is per year or whatever. They should charge more than this so they can make a profit. So this analysis shows them how much they can expect to pay out, so they set their premiums a little higher than that. You guys with me? Same thing with earthquake insurance, tsunami insurance, whatever kind of insurance. They have these people that are just, actuaries that are just looking at the probabilities and telling them what to set their prices at. The worse we're able to drive, the higher it goes. That's why they ask you all these questions about how far away do you work? Because the longer you got to drive, the higher the probability is you get into an accident. What area do you live in? Because some areas have worse drivers, so they're going to raise your premiums, right? I like the good student discount. They're assuming if you get good grades, somehow it translates to be a better driver, but personal experience is actually opposite. Okay.
Did you get good or bad grades in school?
Huh? Good enough, let's say. Yeah. I always like to say my report card sometimes had personality because I had 3 jobs going to college, so I couldn't do every single homework assignment, right? So mine wasn't it was yeah.
So you were an okay driver.
Yeah, I was right in the middle, basically. Well, anyway, you can get different opinions from my friends. Okay, I like that example. Here's something else I want to show you. This would work with like lotteries, casino games, right? Let me show you. Let me see. There's a problem in the homework that is this little. Let me create like a really quick little betting game, right? Let's say I have 4 white marbles and 6 red marbles in a bag. And I say, if you pick a white marble, I pay you $10. But if you pick a red marble, you pay me $9. So if I calculate the expected value from this, if it's positive, I'm going to play the game. Because over the long run, that means I expect to get money flowing towards me. If the expected value is negative, I might not play the game unless I'm a really big gambler, right? You guys kind of follow? So let's see. So if I set this up, I need X, P of X. What am I going to put here? How many rows will there be? Let these guys sleep. Why did I log in? How many rows will there be? How many outcomes are there? 2. So there should be 2 rows. And what numbers am I going to put in there? Numbers related to the... There's just no way to get you out of the way. What am I going to put here? For example, it doesn't matter. What should go here? What's the outcome of either of these? Money. So on this first one, I'm getting money, right?
Yep.
So I'm getting $10. Or you're getting 10, but let's do it from your perspective, right? I'm doing the game, you get $10. On this one, what am I going to put? I'm not going to put 9, I'm going to put
Negative.
because it's flowing away from me. Or you, right? What's the probability you get $10?
44.
Yeah, 4 out of 10. So 0.4. What's probably you lose $9? 0.6. So what is the expected value of this? Will you gain money or lose money in the long run? 10 times 0.4 is 4. What's 9 times 6? 54. So you just put a point in the middle, negative. And when you add those, you get negative 1.4. So on average, you would lose $1.40 per game. Do you ever lose exactly $1.40?
No.
What's the only thing you could lose every time you play the game? $9. But if you played the game a lot, you would average a loss of $1.40 each game. Every casino game has a negative expected value, so that overall the house takes money in. Will there be a person over here winning $3 million? Yes, there will be. Will there be 3 million other people losing more than that? Yes, right? So overall the house is like, Take the 3 million. We don't care. We just made 8 million over here. Who gives a shit? Have fun. You guys with me? A little bit? If you don't go to a casino, if you don't go to a casino and don't watch the news, that's a good life. Just keep enjoying that shit. Casinos are so depressing to me. So it's just, yeah. They used to have to do this, and I just push a button. Okay. I like it. Last thing I want to show you, and then I'll let us out of here a little early. If I just put this up here, what's the average of those numbers? 2.5. Now, if I put this here, the average should be much closer to what? What's the heaviest weighted data point? 1. That's the one that occurs the most. So the average is going to be much less than 2.5, much closer to 1. It's dragging it towards it, right? I always think of this as having a high gravity. So let's calculate the mean. Verify. So I get 0.8, 0.2, 0.15, 0.6, 0.6, Jeff. 2. And then you get 1.35. Yep. There you go. So the average of these data points is 2.5. But with a really heavily weighted data point, it's going to pull the mean towards it. Does that make sense? A little bit? Not much at all? Okay. All right, so what we just did today was we got through section 4.1, and I think, if I'm not mistaken, yes, 4.2 also. Yeah. That's plenty. Good job, everybody. I'll see you next week.
We're getting out early. You go how to break down the formula what you said.
True.
You get X squared plus X minus X squared.
So,
Can't get normal math twice.
Oh, like it's been a while. I might be at the living room. I don't know where that's at. The one next to the state exit. Oh, okay, right there on the. But I'll let you know when. Okay, there we go. Okay. Knock it out.
let me stop here for a second. Basically, we're almost there. It wasn't really a lot. I just didn't want to get lost in this.
That really has to do something with the XPX converting to a U.
Exactly.
Squared
That is
plus
mu.
U squared.
So you get minus 2 mu squared, right? Plus, what's the sum of phi of
Okay,
x?
why is the 2 mu outside the summation sign?
Because what's the summation sign care about? I mean, what is mu? It's a constant. So it's just distributing out the greatest common factor. Yeah, you have a list of things that are adding, I can just take out the common factor. The sum is across all the x values, so anything x related has to stay
Anything
aside.
addition, if you can pull out from the entire.
I can pull a constant out. These are not constants though, because they depend on what x is, so they stay in.
So then you pull that out, it becomes.
So what's the sum of x p of x? Mu times mu is mu squared. What's the sum of p of x? 1.
And plus U squared. Because the sum of all the vectors is going to be 1.
Yes, there you go. So that sum is the mean. Bam, that sum is 1. Bam.
Okay.
So, my Tyler is just gonna drive me insane. So, like, when I go to the one of our stats, or like just an example, it doesn't take
Oh, yeah,
show
yeah.
the thing.
So what you do instead is, if you wanted to do the What were you trying, the L1, L2 one? You just have to put L1, comma L2. I always forget to say that for the older.
Did I have to put like a little comma?
Yeah.
Like,
Yep. That's why there's punctuation in the calculator, yeah.
okay, because I tried that, I was like, when you were doing it, I was like, wait, why is the more? It's like,
Yeah, I start to forget now because more and more calculators have the new style, but the old style, of course, it's a little easier. It's more direct actually. Just tell it exactly which lists.
But it's 24. It's like I have one and it does this and like what yours did, and then I get this one is like slightly different. Like,
Yeah, so they're in 84, but it's just got a different operating system. So I could upload the new operating system. You know, I could have the school do it maybe.
now I'll just remember the comma and like I'll
Yeah.
get lucky
Oh,
the
get
next
on
time
the
I have to
topic.
turn it in. All right, thank you.
Sure.
I'm confused on how this works out. For number 4.
Where'd my calculator go? There it is. Sorry. What's up?
For number 4 and how these numbers. Is how like, so this, how'd you plug in basically the numbers and then the
Are you
special-
cool with the formula, right?
Um,
Probably A and B is probably B times probably A given B. Probably B I know is 0.4. Probably A given B I know is 0.85.
Okay.
So then I just multiply them together. So I wrote the formula down for what it was asking me, and then I filled in what I knew.
Mm,
Yep.
so then this you just broke it apart into a formula.
Well, I have to. They ask me this question. There's a formula to calculate what the and is.
Okay.
And then I just take what I know and throw it in. If there was a part I didn't know, I'd say, okay, is there a way to find out? What I
So is this like what we do here?
No, no.
It's not.
You could use formulas for this stuff, but it's so much easier just to count. I don't need the formulas for this.
Oh.
I can just count what I need for the probabilities. Here,
here we
all I
have to use
have
the
are these numbers. I can't count anything. I have to use the formulas.
Okay.
Yeah. So you know I'm going to give you a problem where you don't need the formulas, and there's going to be at least one problem where you do.
Oh, what I was trying to say exactly is just, it's like, similar work. It's just this one you have to use the formulas and this one you don't.
Exactly. Yeah. Same
So-
idea, just there's a
Okay.
quicker way to get this answer. Because I can just see
The numbers.
all the
and- but
possibilities.
here
Yeah.
you have to.
There I can't see the possibilities.
Okay.
I have to work with the values. So I need the formulas. So I can plug stuff in.
Okay.
Cool.
All right. Thank you.
Sure.
Are you having an office hours again?
Oh, yeah, yeah.
I wanted to go over some questions on my last test.
Okay.
Was this something you showed us? Or was it like, I know there was a few things that like, don't do it this way, I'm just gonna show you. Was this one of them, or should you know how to like?
No, what this?
Yeah.
This is nothing I showed you. Nothing. This is just something that Jacob, that I said, if you were curious about how this becomes this,
Yeah.
this is how that happens. Do you have to know this at all? No.
Oh, okay.
You just put this formula down and use it. Yeah.
Okay.
Yep. But that's just the math behind how that becomes this. Yeah. Yeah. It wasn't that long. It's just kind of weird in the middle. I didn't want to. We don't have to know how to work with these symbols with algebra yet.